Okay, this is a recap of test number 5 for those of you who are going to be attempting to do the retake. I'm going to be using Form A. So if for those of you who had a different form, just make sure you notice which problem it is that I'm doing. Every single problem in Form A, it's on Form B and also in Form C and also in Form D. So you just got to look at where it is on your test to figure out which one I'm doing. So again, I'm using Form A. Let's start with number 1. Alright, so number 1 says, which is a graph of an even function with a positive leading coefficient. Now, when it says even function, it really should say a function of an even degree, not even function. But we're going to go with a function of even degree in order to figure it out. Okay, so before I actually do it, I want to just quickly explain how we can tell that the leading coefficient is going to be positive and that the degree of the graph of the function is going to be even. So I'm going to do a couple of quick examples just to show you guys how easy that is to tell. Okay, so what I've written here on the side is a bunch of examples that I want to do to show you guys how easy it is to determine the end behavior of a function. Okay, which is really what this problem is asking you. It's asking you for a graph of even degree with a positive leading coefficient. That really means it's telling you, can you identify the end behavior of the graph based on that information? Okay, so leading coefficient, what they mean by that is this number in front of your function. Okay, it's always the coefficient of the a monomial with the highest degree. So if you look at your variable with the highest degree, whatever's in front of it, that's the leading coefficient. Okay, so I'm going to do all 8 of these to show you guys how easy it is to tell. So the first thing you check if you're determining the end behavior is this value, a. That's your a value that you guys always see in your polynomial functions. So look at that value and ask, is it positive or negative? That's the first question you ask. If it's positive, then there are 2 possibilities of what could happen. If it's positive, your right side of your function is going to go up every single time. Okay, so your end behavior, there's a left side and a right side, right? Let me write that down so you guys can see what I'm talking about. Your end behavior, there's a left side of your graph and a right side of your graph, right? So when we talk about end behavior, we're really asking what's happening on the left side of the graph and what's happening on the right side of the graph. How is the graph behaving on those sides? Okay, and when you guys look at the A coefficient here, look for its sign. If this is positive, then it tells you that the right side is going up. If this number is negative, then it tells you that the right side is going down. This number right here, the leading coefficient, only cares about the right side of the graph. So it tells you if it's going up or down on the right side. So for example, this one is negative. That means that on the right side, this graph is going down. This one right here, the second one is negative, so that means that on the right side, it's also going down. And you could keep going like that. This one is positive. That means that on the right side, it's going up. So the A value only worries about the right side of the graph. The N value, this is N, the power, the degree of your graph. What it cares about is how the left and the right side are related to each other. Okay, if this number is even, we don't care about positive or negative. We're not going to have negatives up here. Okay, what we care about here is even or odd. If this number is even, that means that they're both the same. The left side and the right side have the same behavior. If this number is odd, that means that the left side and the right side have opposite behaviors. Okay, so let me recap everything. A positive means that the right side is up. A negative means that the right side is down. And even means that they're the same. They have the same behavior. And odd means that their behaviors are opposites. The right side is opposite to the left side. So using that information, watch what we can do. A negative, that means down on the right. And even, that means that on the left, it's also down. Because they have to be the same. Since this is even, they have to be the same. Look at the next one. Negative means down on the right. Odd means that they have to be different. So if this is down, that means that the left side must be up. And then you could continue that pattern for all of them. Let's finish it. Positive A, that means up on the right side. Even means that they're the same. So this one must also be up. Like that. Next one. Negative a. That only, remember, that's the first thing you check. That means only look at the right side. This only determines the right side. So negative means down on the right side. Positive, odd 5 right here. The power is odd. That means that they're opposites. So if this one's down, this one's up. Watch again. Negative, that means down on the right side. Even, that means the same. So they have to be the same. If that one's down, this one must also be down. Alright, keep going. Positive, that means up on the right side. Odd, that means they're not the same. They have to be opposite. So if that one's up, this one must be down. Last two. Positive, that means up on the right side. Power is even, which means that they have to be the same. So this must be up on the left side as well. There you go. You should be now understanding the pattern here. Last one. Power here, the A value is negative. That means that on the right side, it goes down. The power here is odd. That means that they're not the same. They're different. So if this one's down, this one must be up. And there you go. You can easily tell how the graph behaves on the left side and on the right side by looking at the A, by looking at the A value and the N, the power. So now we can do this. Watch. Which is a graph of an even function. That means that the power is even here. The degree is going to be even. So that means that they both have to be the same behavior, right? It's either down on the left, down on the right, or it's up on the left, up on the right. They have to repeat the same behavior. So that pretty much right away eliminates A. Because if you look at it, it's going down on the left, but it's going up on the right. We want even, which means that they should be the same. B is not eliminated. C is eliminated, right? Because it's going up on the left, down on the right. And D is not eliminated because it's going the same direction in both, right? Down and down. And this one is going up and up. Okay, so it's either B or D. So the last thing we're going to check is the other requirement. It says even function. It's either B or D. Positive leading coefficient. That means that A is positive. What that tells us is that it must be up on the right side, right? So the only one of B and D that is right is that one. The answer is that one in this case. Because it's positive, that means up on the right side. Because it's even, that means it repeats the same end behavior on both sides. Okay, let's move on to number 2. It says choose all the statements that are true about the graph. So we have this graph right here. We need to choose all the statements that are true about it. Let's go through each one and see if they make sense in this case. A, the x-intercept is 9. That means that it crosses the x-axis at 9. So it's easy to check. Just look at the x-axis. Yes, that's true. Alright, circle that one. It crosses the x-axis exactly at 9. B, the y-intercept is -2. That means that it crosses the y-axis exactly at -2. So if we check the y-axis here, that's not true. It does not cross. It would be crossing here. It crosses at -3. So that one's not true. Alright, next. C, f of x, that means the function, the y value, is increasing everywhere. That means that no matter where you are, the y value is increasing. The way you can answer that question is by looking at the slope. If I walk from left to right, am I always increasing? Yes. So that one is true. Which makes D not true. F of x is not decreasing everywhere. So again, it's increasing because it's always going up. From left to right, the slope is always positive, basically. Anywhere you check, it's going to have a positive slope, positive rate of change. E, f of x has a local maximum at 1, -2. I told you guys to think of maximums as bumps, hills. So I do not see any hills in this graph, right? A hill will look something like that, right? Something like that. I don't see anything like that in my graph. So no, there is no local maximum. Also F, there is no local minimum. That point that they're looking at, 1, -2, is this point right here, which is actually the point of symmetry of this function. Now that we have learned it, it's a cube root function. So this is the point of symmetry. But no, it is not a local maximum or a local minimum. So no E, no F. G, f of x is negative when x equals 9. Okay, f of x, if you have trouble understanding that, think y. The y value is negative when x is less than 9. So before you get to 9, the y value is negative. You can check that. Before you get to 9, x equals 9 right here, is the value negative before that? Is the y value negative everywhere on this side? The answer is yes, right? No matter what you check before 9, right here, for example, the x value is 7, but the y value is negative 1, right here. And you could check anywhere, right here. The x value is 3, but the y value is negative 0.75, right? So anywhere before 9, the y value is negative. So that one is true. And finally, the function is positive when x is greater than negative 2. So it's saying that from negative 2 and to the right, the y value is always positive. That's not true. From here, you can see the y value is negative, 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 negative. It only becomes positive after 9, not after negative 2. So those are the only 3 that are true for this function. For this type of problem, all you got to do is just check each one to see if it makes sense with the graph. And that's about it. Alright, moving on to number 3. Which of the following statements are true about the polynomial function p of x? So here's a polynomial function p of x that behaves in this way. Kind of weird. But it's telling me a bunch of statements about it that we have to check to see if they're true or not. Start with A. The degree of the function, this function's name is p of x, okay? So don't get confused because they use p instead of f, okay? They're just calling it p of x. It's a polynomial function. That's the name they chose. The degree of it is even. Remember, I just talked about that in problem number 1. Even means that the both behaviors, the left side and the right side, are the same. So it's either up, up, up on the left, up on the right, or down, down, down on the left, down on the right. And for this one, I can see that on the left, it's up. On the right, it's up. So this is true. It does have an even degree because it's up on the left, up on the right. B, the degree of p of x is exactly 4. The degree is exactly 4. That means that this is a graph that is something x to the 4th, right? That is the highest degree, x to the 4th. The way to check that is by checking how many zeros, how many x-intercepts it has. 1, 2, 3, 4. 4 x-intercepts. But if you guys remember what I said about the way that the graph approaches the x-axis, right? It can either cross or it can be tangent, like here. Every time that it crosses, that means that that power only happens once, or 3 times is an odd power, right? And every time that it touches, that means that the power is even. So it could be x minus 2, x minus something squared. Okay, so let me just rephrase what I just said there. Let me erase this and show you guys exactly what I mean. Okay, if I were to tell you, find the function, the equation for this function, you would say, well, the x-intercepts are x equals negative 2, x equals negative 2, x equals negative 1, x equals positive 3, x equals positive 5, right? Those are the x-intercepts. Those are where it crosses or touches the x-axis. So then if I say, okay, take those x-intercepts and turn it into a function, you would do this. You would say, well, the function is p of x equals x plus 2. Where did that come from? From this minus 2, right? X plus 2, x minus 2. If I solve this, x plus 2 equals 0, it's going to give me x equals negative 2, right? Each one of these comes from a particular factor. X equals negative 1, the factor that gave me that is x plus 1. X equals 3, the factor that gave me that is x minus 3. And x equals 5, the factor that gave me that is x minus 5. Right? You recall something like that. And then what I said, if you're going to try to figure out the exact function, is you got to look at each one of these, all of these, and see if it crosses or touches at that exact point. Okay? Does it cross or is it tangent? At negative 2, it crosses. Leave it alone. But at negative 1, it's tangent, so square it. That's squared. Or it could be to the 4th power, or it could be to the 6th power. All we know is that it's an even power because it's tangent at that point. It doesn't cross. At positive 3, it crosses, so leave this one alone. But at positive 5, it's tangent again, right? It bounces off. It just touches it and keeps going. So right here at positive 5, it touches its tangent. So that means that the power here must be an even number. Let's go with 2 again, because it's the easiest one. We don't know for sure if it's 2. It could be 4. It could be 6. Okay? Could be anything that is even, but it's bigger than 1 for sure. So now that we can answer the next question, it says the degree of the function is exactly 4. And now if you look at this, what we wrote here, that's not true. Because this is x to the 1, x squared, x to the 1 power, x squared. If you put them all together, that's x to the 6th. At least, because remember, these could be bigger than 2. It could be 4, it could be 6. So it's at least x to the 6, maybe even bigger than that. So it's not 4. You can cross that one out. The leading coefficient of p of x is negative. We kind of already answered that one. The leading coefficient of p of x is negative. If the leading coefficient is negative, that means that on the right side it's going down. That's not true. So not that one either. Cross it out. The degree of p of x is at least 6. We did answer that one. We said that the degree is not 4 because of what we did right here, right? 1 plus 2 plus 1 plus another 2, that's 6. So that one is true. It could be 6, could be more, but it's at least 6. The graph of the function has a y-intercept at 150. That one's pretty easy to check. Check the y-axis, check the y-intercept. It's negative 150, not positive 150, so no. And finally, p of x has 4 distinct zeros. Zeros is another word for x-intercepts or solutions. And that answer to that is yes. 1, 2, 3, 4. It crosses or touches the x-axis at 4 different points. So that one is true. There you go. Alright, here we go, number 4. There's a graph given to you. It says the graph of g of x is shown. Write the rule for g of x and then describe the transformations used to obtain the graph of g of x from the graph of its parent function, f of x equals x cubed. Okay, so they are telling us that it's a cubic function, and they want us to figure out what exactly the function is based on the information they have given us. The first thing you should do here is identify some points that you're going to use. Okay, especially the most important point, which is the point of symmetry, the one right in the center of your graph. If you follow this graph through, your point of symmetry should be right in the middle of the graph. If it had a middle, it doesn't actually because it keeps going forever. But if it had a center, it would be somewhere around here, right? Because that will be where the graph switches from curving this way to curving this way, right? It'll be right at this point right here. The way you can think of it is, look at the graph and find that space where it's kind of horizontal. Right in the middle of that, that is your point of symmetry. So we're going to label that one. It looks like it's this one right here. And the coordinates of that point are, if you look carefully, this is -2 and this is -4. So right between them is -3. The x value is -3. And the y value is, if you guys look carefully here, it's a different scale. This is -4, so that must mean that this is -1, -2, -3. -3, basically. Let me erase that and write it again, so it looks weird. -3, -3. That's that point. We need another one. You always need a point of symmetry, your most important point, and then you need another one in order to solve. So let's look through the graph to see if we can find another one we can use. Now if I go down the graph, I found this one. That one works. It looks like it crosses that point exactly at -4, -5.5, and +5. I don't like that 5.5 part. Okay, so let's see if we can find a better one. Right here, look at this one. This is -4, so this must be -5, +1. That one works. Let's use that one. So let's label that point right there. And it's -5, +1. That's a negative right there. -5, +1. Again, just make sure you're checking the scale, since this is -4 and this is -6. Right in between them is -5. And this scale is going by ones, so it's +1. That's what we're going to use to solve it. Next, the steps are the same that I've been showing you guys. What you're going to do is write B, H, A, and K. because we're gonna try to figure out what the function is, and these values will give me what the function is. X and g of x. Same 6 parameters every time, same 6 values every time. We're trying to find b, h, a, and k, but we're not going to use both b and a. Okay, either b or a is what you're going to use, and then you choose, guys, what your best option is going to be. You don't have to choose one or the other in these cases. You choose the best option. I'm going to choose a because I feel like most of you guys would have chosen a. You feel more confident with a. So let's solve for a instead of b. Next, what you do is, from the points that you guys found, the one in the center, this one is your most important one. This one gives you your h value and your k value. So this is h and this is k. So now we know that h is -3 and k is -3. That point right in the middle tells you h and k. The other point, the one that we chose to use, -5, 1. And by the way, maybe somebody else chose this one up here. That's fine. Maybe somebody else chose this one down here. That's also fine. It should give you the exact same answer. Okay, it does not make a difference in your final result. So -5, 1. That means my x, -5, 1 determines your x and your g of x. Okay, let me write that down. This is x, g of x. This one is h, k. That's what those two are. So hk is the one in the middle, the center, the point of symmetry. X and g of x is the other point, whatever other point you choose. So x is -5, g of x is 1. You take those 4 values, you plug it into the general form we're going to use, and we're going to solve for a. So the general form looks like this. G of x equals, since I'm using a and not b, my general form is going to look like this. A times x minus h, notice that I just completely ignored b, cube, don't forget that this is a cubic function based on what they told me here, plus k. Okay, now you just plug in all the values that you know. G of x, in place of g of x, I'm going to plug in 1, so put a 1 right there. A, we don't know. X, in place of x, I'm going to plug in a -5. Minus h, careful there, minus h. H is -3, so what you need is minus -3. So what I'm actually going to write is +3. So be careful with that one. Don't forget the cubed here. Plus k, k is -3, so once again -3 right there. And then we're going to solve that for a. First thing I'm going to do is kick out the 3. That's 4. Also, as I do that, I am going to clean up the inside the parentheses. That's -5 plus 3. That's -2. So -2 cubed. Now I'm going to take care of the cube. -2 cubed is 8. -8, I mean. So what I have is 4 equals a times -8. Now I want to write that simpler. So it's 4 equals -8a. Yeah, that's better. And now to solve for a, all I got to do is just divide by -8. Divide by -8. That cancels. So a equals -1/2. Right? 4 divided by -8, -1/2. The hard work is done, but you're not finished. Remember to finish your problem by writing out the function. That's the question. Write the function. So what you're going to do now is write this, but plug in a h value, an a value, and a k value. You do not, at this point, need x or g of x. You use them just so that you could find a, which we just did. It's -1/2. All you care about now is h, a, and k. Plug those in here, h, a, and k, and you're done. So my final answer looks like this. G of x equals a, which is -1/2, times x minus h, minus -3 means +3, cubed, plus k, which is -3. That is your answer. Okay, so I was going to move on to number 5, but then I realized that I only did this one assuming that you guys would choose A. But I know that there are some people who choose B, so I want to show you guys the exact same problem, but what if somebody chooses B? Right? Because in the instructions, I didn't tell you which one to choose. You have that option. So just to show you guys that you can still solve it same way, instead of A, we're going to find B. So my H and my K value are the same. My X and my G of X values are the same. But in this case, what I'm going to do is cross out A. We don't care about that one. We're going to solve for B. And also, this is the form we're going to use, right? We don't care about A. We care about 1 over B, which is inside of the parentheses. So the steps are the same. Let's plug everything in. G of X is 1, so we're going to put 1 for G of X equals parentheses 1 over B. We can't replace that with anything because we don't know what it is yet. X minus H, that means negative 5 minus negative 3, so plus 3. All of it cubed. Plus K, which is minus 3. We're going to clean up the exact same way we did before. I'm going to add 3 here to send it to the other side. That's 4. 1 over B. I'm going to clean up inside these parentheses. Negative 5 plus 3 is negative 2. Cubed. That's what I have. What I'm going to do is still clean up inside these parentheses. Look at what I'm going to do, okay? What I'm going to do is I'm going to multiply 1 over B times negative 2 to make it a little bit easier and cleaner to see. So it's going to be 4 equals negative 2 over B cubed, like that. Okay? And now it's going to get a little bit messy, and this is the reason why some of you guys prefer to use B instead of A. So what I'm going to do to finish it is I'm going to cube the right side. So 4 equals negative 2 cubed. When I say cube the right side, I'm going to cube this and cube this. Okay? So negative 2 cubed is negative 8. And B cubed is B cubed. You have to cube both the numerator and the denominator. And now to finish it, what I'm going to do is I'm going to make a proportion here and cross multiplies to not make my life difficult. 4B cubed equals negative 8. I'm going to divide by 4 to solve for B. B cubed equals negative 2. And this is where it's going to get messy. Okay, so far all we did was make a fraction here so I could make a proportion, right? I cubed this first, then I made a proportion to solve it. I came up with B cubed equals negative 2. Now to finish it, what you need to do is take the cube root of both sides, because that's the only way to cancel B cubed. Take the cube root of both sides, and you're going to end up with B equals cube root, by the way. I forgot to write the little 3 there. In order to cancel cube, you cube root. We're going to get B equals... The only way I'm going to be able to do that, because I don't know what the cube root of 2 is, it's not a perfect cube, is punch it in the calculator. B equals 1 point, according to my calculator here, 1.259, let's leave it as 1.26, negative 1.26. That's what my calculator says. Okay, so that's your B value, 1.26. And now when you plug it in to write your function, it's a little bit of a challenge because your B value is a fraction. So it makes it a little bit difficult. Okay, but we can still do it. So plugging in means I don't care about X or G of X anymore. All I care about is B, H, and K. Those are more important ones right now. So we're going to plug them all in into this right here. So it's going to look like this. Watch. G of X equals, parentheses, 1 over B. So 1 over 1.26. Since this is a decimal here, and we chose to leave it as a decimal, the best thing you can do is actually divide 1 divided by 1.26 to see what your calculator says. Punch it into your calculator. Mine says 0.79. Negative, right? Oops, I keep forgetting the negative. Let me fix that. This is negative 1.26. Not positive 1.26, negative, this is negative. So negative 0.79 is what goes there, right? Again, we don't put in B, we put the reciprocal of B. This is the reciprocal of that because it's 1 divided by 1.26. And now everything else is the same. X minus H, which is X plus 3, cubed, plus k, which is negative 3. That is your final answer if instead of choosing A, you chose to find B. And you can see why most times, if they given the option, we will choose A because it was a much easier process, or less messy. It wasn't easier, it's less messy. This makes it a little bit messy right here at the bottom. Okay, next, number 5 says draw a graph of an odd function with exactly 2 real zeros and a positive leading coefficient. I told you guys that to change the where it says odd, change it to even. That way we could do it. Okay, even function. And when I say even in this case, I really do mean the definition of an even function. Okay, which means that if I graph it, it's symmetrical about the y-axis. So it has perfect symmetry. It means that when I plug in a negative x into the function, it's going to give me back the exact same. That's what the definition of an even function is. If I plug in a negative x, it's going to give me the exact same thing as if I plugged in a positive x. That really means that the left side and the right side from the y-axis are exactly the same thing. Okay, they're symmetrical to each other. So that's what we want, an even. So we're going to fix that right there. Should say even, not odd. With exactly 2 real zeros. That means it crosses the x-axis twice. So let me highlight some of the important information here. Okay, it must be even. It must have exactly 2 real zeros, and it must have a positive leading coefficient. So that's a lot of information there. Okay, but if you guys look back at example number 1, everything that we practiced there, you should be able to handle this one now. Okay, even means symmetrical, so it has to be symmetrical about the y-axis. 2 real zeros means that it crosses or touches the x-axis twice, exactly twice, only twice. Positive leading coefficient means that it's going up on the right side, right? Remember what we said about the leading coefficient, the a value? That means that on the right side it's going up. So I know that for sure. Let's start with that. On the right side it's going up. Let's undo that and fix it. On the right side it's going up, like that. I also know that it's symmetrical, because it's even. And I also know that it has to cross or touch the x-axis twice. So if I cross it or touch it once here, I must touch it or cross it in the exact same spot on the other side. So just choose where you want to cross. Doesn't matter. Just choose where you want to cross. I want to cross 3. Why not? There you go. That means that I also have to cross at negative 3. Why? Because it's even, and because it has 2 zeros. So if I cross here, I have to cross again over there. It's even, that means it's going to be symmetrical, and it crosses twice. Positive leading coefficient means that it's going up on this side. Since it's even, that also means that whatever is happening on the right side, it's happening on the left side. So it must also be going up on that side over there. And it's going to look something like this. So just make it somewhat symmetrical. You could draw a parabola, but it doesn't have to be a parabola. Just anything that is exactly the same on the left as it is on the right, and that it crosses at negative 3 and at positive 3. Right. Hey, kind of. That worked out. That's what I was looking for. Something that looks somewhat symmetrical, and that it crosses the x-axis at exactly the same spot on both sides, and that it's going up. It has to be positive leading coefficient, so it has to be going up and up. And that's it. Many people came up with different ways to write it. Here's another one. Look, let me erase this one. Here's another shape that you could have drawn. Some people chose to, let's say, choose negative 2 and also positive 2. But they didn't want to cross. They wanted to be tangent. That works. Is it symmetrical? Yeah, somewhat. Does it touch the x-axis twice? Yes. Is it going up? Yes, that works as well. Okay. As long as it's symmetrical, it goes up and it touches the x-axis or crosses. The other one was crossing the x-axis twice. You're good to go. Okay, number 6. Number 6 was probably the easiest problem on the test. Okay, but a lot of people missed it because you did not read it carefully, or you read it but you did not understand what it was asking for. Parent function is something we've been talking about a lot. Parent function means the most basic form of the function, right? It's the basic form, the one we start with. So all you had to do was look at this one right here and tell me what is the most basic form of this type of function. What is the parent function for this? And your answer should have been easy to come up with. It's f of x. Oops, let's fix that. wrong one, f of x equals x cubed. That's it. That's the parent function. Then it said, describe what transformation of the parent function it represents. So first, tell me what the parent function is, and then give me a description of what happened to the parent function to make it this one. So what you have to do is just look at it, see which parameter is given to you. Did they give you B? Did they give you H, A, or K? What is it that they gave you? And then tell me what happened then from that parameter. So if you look at it, it's actually very simple. There's only one parameter. There's no B, no A, no K. That's H. H is -3 in this case. So what you got to say is H is -3. Therefore, this is a shift to the -3, guys. That means left 3 units. And that's it. That's all I needed for that one. Tell me what the parent function is. The most basic form of this function. That's that. Okay, parent functions are always going to look very, very basic. If I told you, for example, tell me the parent function of f of x equals 3 radical x plus 2 minus 7, then you would say that the parent function is radical x. That's it. What type of function is it? It's a square root function. So what's the parent? That one. And so on. Whatever function I give you, look for the most basic one. That's the parent function. And then if I say describe the transformations, here you would say, well, A is 3, so that's a vertical stretch by a factor of 3. Here you would say, well, H is -2, so that's a shift to the left 2. K is -7, so that's a shift down 7. That's what I want for those problems. Alright, number 7, graph the polynomial function p of x equals the quantity x minus 1 squared times x plus 1 times the quantity x minus 4. So there's 3 factors here in this function, and we're going to use them to graph. Okay, the easiest, best way to graph this is by using the x-intercepts that come from here, and using the degree, the power of each one, to tell if the graph is going to be crossing or being tangent or touching the x-axis. And finally, you also need to find the end behavior. Look back at problem number 1 where I explain everything about the a value and the n value to determine the end behavior. In this case, we're going to start with that end behavior. A here is positive, right? The a value, whatever is here, is 1. It's positive. So that means that basically my leading coefficient is 1, positive 1. My power for this function, my degree, comes from multiplying all of these by each other. We're not going to do that. All you got to do to determine the degree is say, well, this is x squared, because x, and then there's a square there. This is x, and this is x. So if I put them all together, x squared times x gives me x to the 4th. That's what you have. So using that, now you can tell the end behavior. Positive means that on the right side it's up. Even, an even power, means that you have the exact same behavior on the right as on the left. So it should be up on the left as well. That means that my graph goes up on this side and it goes up on that side. I don't know exactly where it is, but I know that that's what's happening. Next thing you do is identify the x-intercepts. All of them come from here. Remember, just take each one, and in your mind what you got to do is set it equal to 0. It's x minus 1 equals 0, therefore x equals 1. That's what your x-intercepts are going to be. So it's x equals 1, x equals -1, right? This one gives me positive 1, but this one gives me -1, and this one gives me positive 4. X equals 4. There you go. Those are my x-intercepts. What you're going to do with those is you're going to plot them in the graph. 1 right here, -1 right there, and 4 right there. So those are your 3 x-intercepts. And you're ready to graph. Using this arrow, I'm going to connect these dots. I'm going to touch this one, cross or tangent, I don't know yet, but I'm going to touch it for sure. And then I'm going to touch this one, and then I'm going to touch this one, and then I'm going to go up. That's basically the idea. The last question before I actually do it is it going to cross or is it going to be tangent? So the first one we're going to encounter is -1, which is this one right here. What you got to do before you actually draw it is say, well, that's -1. That's the first one I need to get to. This -1 came from here, not this one, right? This gives you +1. The -1 came from here. look at the degree of that, the power of that. The power is 1. If there's nothing written, the power is 1. That's odd. If the power is odd, cross right through. If the power is even, do not cross. You bounce off the graph. You're tangent to the graph. Okay? So for this -1, which came from here, which came from here, we're going to cross. Cross right through. Approach it and cross. Kind of missed a little bit, but that's the idea. Next, you gotta go to the next one. I'm gonna go to that one next. I need to hit it somehow. I don't know if I'm gonna cross it or touch it, but I need to hit it. Okay, pass through it. So that one is +1. That came from here, which came from here, and the power there is 2. If the power is even, don't cross. Your tangent. Okay, even is tangent. Odd crosses. So that one's going to be tangent. So don't cross through. You're going to basically bounce off of that point, come back down. Touch it, and then come back down. Next, you got to hit this point over here. And again, ask the same question before you cross through. That one came from here, which came from here. That power is odd, so you're going to just cross right through. Cross and go up. It's okay that I didn't use this arrow, as long as I'm still going up at the end, right? This arrow also kind of messed up my graph. As long as you're still going up, you're following the correct end behavior, you're fine. Sometimes the question I get is, how far down should I go? How far down or how far up should I go if for some reason it's up here? And the answer to that is, you're just doing a sketch right now, okay? If we wanted to for sure tell where you were, how low your minimum is going to be for these two, then we would ask you to plug in the actual value between 1 and 1, which is 0, and that will tell you exactly where it is. And we would ask you to plug in the value between 1 and 4, which is 1.5, and that'll tell you exactly how low this point is. But we don't care about that. What I care about in this case is just, can you tell me the basic description of the graph, the basic attributes of the graph, where it crosses the x-axis, what its end behavior is going to be, left is up and on the right is also up, where of these x-intercepts, where it actually crosses and where it just touches and comes back down. You're not going to have a perfect graph, guys. This is a sketch. Okay, I think this is the last one I'm going to do in this part of the test review. I'm going to leave the other ones for part 2 because I don't want to make this video like an hour long or so. So I'm going to leave it right here. This is the last one, and then I'll pick up on another part on another video. Okay, so number 8. The graph of a polynomial function is shown. Write the rule of a quartic. That means degree 4, right? Quartic means degree 4. Function that can be represented by p of x, by this function right here, by this graph. Assume that a is either 1 or -1. Alright, so basically the idea here is this. They're giving you the graph and they're telling you, you tell me what the function was that gave me that graph. This is not like any of the parent functions that we have learned, right? This is not a square function, a quadratic function, a cubic function. This is not like any of those functions that we have learned. It's just a general polynomial function that we have to figure out its basic attributes from the graph here. What you do first is identify the x-intercepts. So look at the graph and find out where it's crossing the x-axis, which is right there, and right there. Those things are huge. Let me fix that. Right here, and right here. So it has 3 x-intercepts. I don't see any more. That basically tells me what my graph, my polynomial function is going to look like. It's going to look like this. P of x equals a. I'm not going to check a yet. I will get to a. And then there's 3 of these. 1, 2, 3. Because there's 3 x-intercepts. What are they? What you need to do is figure out what they are exactly. This is -3. So what I'm going to put here is x minus -3. It's always x minus whatever number you have. So really what I'm going to put in there is x plus 3. Right? We're basically going backwards from the other ones where they gave you these things and you had to figure out the x-intercept from them. From this one you get -3. To go backwards you say, oh, the x-intercept is -3. Therefore the factor is x plus 3. The x-intercept is 0. Therefore the factor is x minus 0. I'm going to write it exactly as I said it. We're going to fix that. We're not going to leave it as x minus 0. You're just going to have x in that one. For this one, it's 2. positive 2, so my factor is x minus 2. There you go. Let's fix that. Like I said, the x minus 0, I don't like that. So I'm going to leave it as a in the front still. X minus 0 is just x. So since it's just x, I'm going to write it first. And then x plus 3. And then x minus 2. Okay, almost done. The next thing I'm going to check, still, I'm not worried about a yet. Okay, I'll figure out a at the end. Still looking at the x-intercepts at each of these, you got to ask for each one of them, do they cross? Is it crossing through that point? Or is it tangent at that point? Is it bouncing off that point? Anytime you see a tangent one, you have to put a square on this. Okay, a square or a fourth power or a sixth power or any even power really. Okay, in this one I'm saying square because they're asking us for a quartic. And so if I put a fourth power, it's already too much because it'll be x times x to the fourth, right? So square is the one that's going to make sense. Wherever it is, it's going to be square. So which one is the one that is tangent? Not that one, not that one, that one. That's x minus 2, right? That's x equals 2, so that means that it started with x minus 2. So this one must be squared. Once again, because it's tangent here, it must be squared here. And it doesn't have to be square, right? I could have put 4. So I'm estimating what it is. I could have put 4. However, that would go against what they told me here, right? They want a quartic. And if I put 4, it's going to be x times x to the 4th. That's x to the 6th. Can't put 6 or 8. The only one that makes sense is 2. So let's fix it again. And that should be 2. Oop, that's horrible. Let's fix that. Erase this. Alright, 2. There you go. Alright, now, finally, recap what we just did. I found the x-intercepts. Negative 3 says x plus 3. 0 is x minus 0. 2 is x minus 2. I fixed the x minus 0 to just make it x. Okay, because that looks clearer, looks neater, looks nicer. X minus 2, since I saw that it's tangent, I put a square on it. Anytime it's tangent, the power is even, so we put square. Last thing is to choose the correct a value. Assume you're not going to solve for it for these, okay? The solving process would be way too long and way above our level right now. So all we're going to do is assume that a is either positive 1 or negative 1. You just have 2 to choose from. So look at the graph and choose the correct a value. Is either positive 1 or negative 1. How can you tell? Once again, as always, the leading coefficient, the a value, tells you how the graph is behaving on the right side. What's happening on the right side? Is it going up or down? It's going down, therefore a must be negative. So we're done. P of x equals negative 1x. You don't have to write negative 1x. You could have just written negative x, and that's okay. X plus 3 times the quantity x minus 2 squared. There it is. That's your final function. Or, to make it nice and neat without that 1 there, P of x equals negative x times x plus 3 times x minus 2 squared. Those are the 3 factors. What if somebody chooses to leave it as x minus 0 instead of x? Then they're technically still correct. Okay, it just looks weird, but it's still correct if they left it as x minus 0. As long as they have the a that is negative 1, and they have the square on the x minus 2, that's fine. Maybe some people chose to write the x plus 3 first, then the x minus 2 squared. Technically, you're still correct. It looks weird, but it's still correct. Okay? You basically have to have these 3. This one has to be squared, and there has to be a negative 1. Alright, so that concludes this part 1. I hope to put up a part 2 by tomorrow, so look out for that one. Study if you're planning to do the retake.